Okay, now that we know how to convert between logarithmic and exponential form, we can actually find the exact value of lots of different logarithms without actually having to use a calculator, because our calculator only does two bases anyhow, base 10 and base e. So there's basically two ways you can do this, and really I don't even know that they're that much different from each other. Some people will look at it and not even see much of a distinction between the two methods. But if I wanted to find, let's say, log base 5 of 25, can't use my calculator because my calculator doesn't do base 5, but one thing I could do is set this equal to x, and x is what I'm trying to find, and rewrite it in exponential form. So 5 is the base, x is my exponent, and 25 is the target, and then you can just tell by looking that x must be 2. The second way you could do this, and again, I don't really know that there's that much of a distinction between the two methods, you can say to yourself, what number do I need to raise my base to get the target? So for this problem, I need to say, what do I need to raise 5 to create a target of 25? And the answer is 2. So either way you want to think about it, whether you actually need to write it out, or some of you might be able to do this process in your head. You are, welcome to do that either way you want. It depends on what you're more comfortable with. There's not really too much of a difference between what we're doing there either way. Let's do this one by writing it out. We'll set it equal to x, and we'll write it out in exponential form. So 4 is my base. X is the number that I would raise it to get 16. And what is that number going to be then? Well, I think it's going to be 2, because 4 squared gives you 16. Let's do this one. Log base 3 of 27 equal to x. So 3 is my base. X is the number to which I must raise it. And I have a target of 27. 3 to the what gives you 27? Well, I guess it's going to be 3 to the third. So x equals 3, and log base 3 of 27 must have been 3. If you know some common squares and cubes and maybe fourth powers, especially when you have like small numbers like 2 and 3 and 4, that is probably going to help you do a lot of these calculations. Let's look at this one though. I don't know what this is, but I have 3 to the x equal to 1. And then if I think backwards, what would x have to be to change the 3 into a 1? Well, I think we know anytime we raise something to the 0th power, we get 1. So it must be 0. So log base 3 of 1 gives you 0. Okay, this one, well, my base is e. I set it equal to x there. X is the number I'm going to raise it to, and I want to get e when I do that. So, well, that seems pretty straightforward to me. I think x just has to equal 1. In other words, ln and e cancel out. You just get the number 1. Okay, we'll talk more about that in another section also. Log base 2 of 16 equal to something. What's that going to be? Well, 2 is my base. X is what I need to raise it to. And 16 is my goal that I want after I find the exponent to raise it to. And what will that exponent be? So in other words, what is the value of log base 2 of 16? Well, I think it's 4. Because 2 to the 4th, 2 times 2 times 2 times 2 is going to give you 16. Let's look at this one. Log of 100 equal to x. Well, if I don't have a number here, that means I'm talking about base 10. So 10 to the x equals 100. And what would x have to be to make 10 become 100? Well, I think 10 squared, so that means log of 100 is actually 2. ln of 1. Well, if it's natural logarithm, e is my base. I need to find out what to raise it to, and I want to get 1 after I do that. So what do I raise e to create a 1? Well, I think 0. So ln of 1 is 0. That one you could actually test with your calculator. Let's look at this one. Log base 10 or log 10. Well, because I don't have a number there, it's going to be 10 as my base. Anytime you don't see a number next to the logarithm like that, it's just a base 10. So 10 is the base. I'm looking for the exponent that I want to raise it to, and I want my target to be 10. Well, I guess that means log of 10 is just going to be 1. Okay, log base 81 of 9. So this time 81 is my base. I'm raising it to some power. That's what I'm looking for. That's my logarithm. And my target will be a 9. Now, to change an 81 into a 9, I think I have to square root that. And the exponent that can square root for us is 1/2. 81 to the 1/2 is 9. If you forgot that, let me just remind you, if you have fractional exponents, 1/2 is a square root. So raising something to the 1/3 will cube root it, and so on. Okay, let's look at this one. Log base 125 of 1/5. So 125 is my base. I'm trying to look for the number to raise it to, and I want to end with 1/5 when I do that. Okay, I've actually got two things happening here. First of all, I'm changing a whole number into a fraction. So I think x has to be negative, because that will flip it. But then I also need to change 125 into 5 after I flipped it. So I think to do that, square rooting 125 is not going to work. But if I cube rooted 125, I think that would give me 5. So how do you cube root with an exponent? Well, the exponent must have been 1/3. Now, that's another problem where it's going to be hard to do unless you know some of the perfect squares and perfect cubes. I recognize that 125 was the perfect cube. It was a cube of 5. So we just have to of 2, 3, 4, backwards a little bit. Okay, here's another one. Log base 2 of 1/8. So 2 to the something gives me 1/8. What would I raise 2 to give me 1/8? Well, I think I'm going to need a negative to flip the 2 and make it a fraction. And then 2 to the 3rd would give me 8, so I think I want to use a -3. When you get done with these, if you're not sure if you did it right, go back and plug them in and check. I think if you plug a -3 in there, do 2 to the -3, you are going to get 1/8. Okay, 4 to some power gives me 1/2. Well, to change the 4 into a fraction, I must have had a negative exponent. And then to change 4 into a 2, I could have square rooted it. So that means 1/2 power. That's how you square root. Log base 81 of 3. So 81 to what power gives me a 3? Well, no negatives involved this time, but to make 81 smaller, I think I'm actually going to do the 4th root of 81. So that means my exponent is 1/4. So I just recognize that 4th root of 81 gives me 3, and I know that a 4th root is just 81 to the 1/4 power. So that's how I got that. So again, you need to know some of these smaller powers to help you with these. 4 to what gives me 2. That one, after all the other ones we've done, seems pretty easy. I need to square root the 4, so x equals 1/2. 3 to some power gives me 1/9. Well, I definitely need a negative to flip the 3. And then I have to square 3 to make a 9, so I get x equals -2. And again, if you plug the number back in, 3 to the -2, I think you'll see you do get 1/9. So double check your work. Last one I want to do for you, 1/16 is my base. I need to raise it to some power to get 4. That number is going to be my logarithm. So first of all, to change a 1/16 into a whole number, I think my answer had to have a negative so that I can flip things. And then to change a 16 into a 4, I think I have to square root it, so I need a 1/2. So the negative flips the number, and the 1/2 square roots it. And that's all you do.